So it's helpful to think about how we would use this potential function idea in the context of Q-learning instead of just solving Bellman equations like we had a moment ago. So in the setting of Q-learning, we're going to be keeping some Q function, QSA, and each time we get a state action reward next state quadruple, we're going to update our state action pair for the state action pair that we just left to be the, a little bit more in the direction of the reward plus the discounted value of the state we end up in. And this reward now, we're going to use the real reward, but now we're going to shift it around, mess it around with this potential function. So we're going to take the actual reward, subtract the potential for the state that we're leaving, and add the discounted potential for the state that we're arriving in. And so this is going to be how we do our updates. And so if we run this version of Q-learning, what should happen in the limit?
The right thing.
Yeah, so it should actually solve the original MDP, the one with just R here, and it should ultimately ignore these psi's. So there's a sense in which we don't really care what these psi's are. So what if we choose like this one? What if we say psi of S is the max over all actions of the optimal Q function, Q star, for that state action pair?
You mean the actual true value of being in the state?
Yeah.
Oh, well, first off, if we choose psi to be that, then we're already done.
Well, so yes and no, right? I mean, we only can do this if we've already solved the problem. So admittedly, this is an unrealistic thing to be able to do. But what does it do to Q? What does Q end up being in this case?
0.
Is that obvious? QSA is going to be Q star of SA minus psi of S, right? That's what we figured out on the last slide. And this psi of S is exactly max A Q star SA.
Which is Q star SA.
Not exactly, right? So QSA for the optimal action is 0.
Oh, you're right. I'm sorry. What I just said is true for when you take the optimal action. It is 0.
Right. So QSA in this case is going to be 0 if A is optimal.
And it'll be less than 0 otherwise by a constant for each action otherwise.
Right.
Yeah.
By the amount that it's suboptimal.
Yes, that's exactly right. By the amount that it's suboptimal.
So this is kind of cool. So if you think about initializing your Q function to 0, which we often do because, what do we know? Then it should start off actually doing the right thing. It should maybe take some of the non-optimal actions, discover that they have a value less than 0, and then after that, just take the best ones. So this gives you an incredible leg up on the learning problem.